If you have just joined into this class, this is the grade 11 physical sciences class. This is the grade 11 physical sciences class. Today is the 7th of July 2020. And yes, indeed, we are continuing with electricity and magnetism. This is the chapter that we're busy with right now. And at the current moment, we are busy with, we're going to be doing electromagnetic induction. Okay? I hope that everybody is ready and willing, to get all this information into their minds because we've been about it. We've done electrostatics in Columblo. We've done electric fields. We've done electric field strength. We've done magnetic field of an electric current, magnetic field diagrams, and now we have moved on to electromagnetic induction. Electromagnetic induction is quite a sport because there's quite a lot of things. But what I like about it is that it's basically, this is sort of like an introduction to all the Faraday's laws that we're going to come and do next in the next few days. Okay, so it's all going to come together, but you will understand that once we get to once we get to once we get to the other problems. Okay, so before we go anywhere anywhere far, I just want to mention to you guys that in this class, for electricity and magnetism, according to the ATP that has been adjusted by the Department of Education, they have removed all calculations in this in this unit. So we're not going to be doing calculations. Hence, we haven't been doing calculations. Basically, we've just been going through the theory and the diagrams, the figures, the theory, the explanations, and the definitions. So those are things that you're going to have to know for your exam. And another thing that I want to remind you guys is that for the exam, there's only going to be one paper. You're not going to write two papers like all the other years where there's paper one physics, paper one chemistry. This time we're just going to have one paper, 75 each. No, I think it's 80 and 70. Yes, something like that. But it's going to be one paper. And in that paper, you're going to have to, everything's going to be crammed up. Other things are removed, but everything that is removed, we will get to talk about it as we go on. Right now, we're just going to finish the term 3 syllabus just to get you guys ready and knowing all the information that you must know for the term 3 of 2020. Checking where we're working from. Guys, I love myself, my Oxford Successful textbook, but I also use a Siyavula. I use Study and Master. So whatever textbook that you are currently using, it's all good as long as it's giving you all the information you need and it's CAPS approved. It is most definitely a good textbook, so you can use it. So guys, if you do not have some of the textbooks that you really, really would like to have, you can go on Snaplify. Snaplify is an application that you can download and you can get all textbooks, not just for physical sciences, but for other grades as well. You can get yourself some textbooks, read, and you can find yourself understanding from different perspective of different authors and textbooks that you can get. So please, if you do get a chance, absolutely free until the 31st of December. All these textbooks are going to be free, so you can get them on Snaplified. My name is Nonkululego Madondo. I am your physical sciences grade 11 teacher, and welcome. Okay. Okay. Just having a little slow pace. I think it's because when you've been working, the computer has been on for quite some time as I've been having back-to-back classes, but nonetheless, this is the stuff that we spoke about. This is the homework that I had for you guys today. I ask you guys to discuss the environmental concerns and safety precautions when it comes to relating to transmission lines and transmission line and overhead cables. Basically here, as long as your answers has to do with the safety and health of birds and all things that are flying that could be affected by the lines could, for example, be electrocuted. It's all about people as well. It can be a human concern, especially where they around the electrical waves apparently, but it's not been proven. It can affect the people as well, and we know that yeah, basically those are some of the things that you guys can write about. If you've written either or any of these things, you can just you know explain it. That's all the environmental concerns, but we did all of them yesterday during class. So that's why I didn't want to delve too much into it. I just wanted you guys to do them in your own time and for you guys to understand them more. Okay? So that is it. So for the content today, we've got we're going to be doing electromagnetic induction. So what are we going to learn? We're going to discuss more what is electromagnetic induction. We're going to talk about electromagnetic induction by a moving object. We're going to talk about the current produced by the magnet, because the main point here is for us to understand what is electromagnetic induction, and for us to understand that, we need to understand all the aspects that come around with the whole production of electromagnetic induction. Okay, that is what we're going to be. Okay, I also encourage you, if you have any question that you'd like to clarify, just let me know. Drop me a chat, and I can go back and explain anything that you might be struggling with. So if you do have a problem, just drop me a chat and I'll go back and explain your problem. So that's how we work in this class. But nonetheless, let us start. So electromagnetic induction. What is it? Okay. Electromagnetic induction is a, induction, sorry, I made an error there, is a process in which a conductor is placed in a specific position and the magnetic field remains variable, or the magnetic field is stationary and a conductor moves. Okay, so basically this, if you check the definition, it's got to do with electricity and magnet creating an electrical component and a magnetic component, all creating electricity together. Okay, so that is the baseline of electromagnetic induction. So this generates a voltage or EMF, which is an electromotive force, across the conductor. Okay, don't worry. I'm going to get to how exactly it happens. I'm just for now defining basically the outlook of what is an electromagnetic induction. So in 1830, Michael Faraday invented the law of induction. Okay, so suppose you go, for example, cashless while shopping and your parents use cards. The shopkeeper scans or swipe your card at any time. Shopkeepers or won't take or tap a photo of the card. So why are they swiping or scanning? And how does it deduct money from my card? This is due to the effect of what we call electromagnetic induction. Okay, so electromagnetic induction is called the induction of an electromotive force by a conductor's motion across a magnetic field, or by a change in magnetic flux in a magnetic field. Okay, it will make more sense once you see the diagrams, but for now, let's just get into the concept. So basically, that's what it is. When you're swiping a card, there's those magnetic things that actually scan the card, and somehow electrical energy happens there, and your information is read and you have paid. So that is a process of electromagnetic induction. Okay, so this happens either when a conductor is set in a moving magnetic field. So when you're using an AC power source, or when a conductor is moving in a stationary magnetic field. Okay, so if a magnetic field is created and a conductor moves through there, electromagnetic induction will take place. Or when a conductor is moving in a magnetic field or a stationary magnetic field, basically, then electromagnetic induction will take place. Okay, so continuing, it says Michael Faraday found this law regarding electromagnetic induction. So based on the setup given below, which is this one, he organized a leading wire connected to a gadget to a gauge the voltage over the circuit. Okay, so you see, this is our little solenoid there, and then this is our galvanometer, and this is our magnet. Okay, so the voltage is determined in the circuit as a bar magnet moves through the snaking. The snaking is this part here, you see. So you take the magnet, you put it inside here. Okay, so the voltage is determined in the circuit as a bar magnet moves through the snaking. Okay, so the importance of this is a way to generate electrical energy in a circuit using magnetic field and no longer just batteries. Okay, so machines like generators, transformers, and the motors operate on an electromagnetic induction principle. But you'll know that more once, maybe if you take up physics or electrical engineering stuff further when you finish your matric. You know, they get more into details and you get to understand more in depth of the concept of electromagnetic induction principle. Okay, so it says here, electromagnetic induction is a process by which a magnetic field generates electrical current. It happens when a magnetic field a magnetic field is what basically, once this thing goes in here, there's going to be a magnetic field produced. Remember we spoke about it last, that a magnetic field moving in one direction from one point to another. And in this case, that's what they mean when they said process by which magnetic field generates electric current. It happens when a magnetic field and electric conductor, such a wire coil, move relative to each other within the magnetic field as long as the conductor is part of the closed circuit. So basically, if this magnet is put in here, it's going to be part of this closed circuit. So the current must flow into it as it crosses lines of force. Okay, does it make sense? Well, I hope that it does, but we're still together. So basically, here is what I was talking about. So you see, this is the magnetic field, this is the coil or loop, and then this is our galvanometer. Okay, so similarly, if the magnet is now stationary and the coil is pushed either towards or away from the magnet, the galvanometer needle, so this needle right here, will also travel in either direction. The action of a moving coil or wire loop through a magnetic field then induces a voltage in the coil, with the magnitude of this induced voltage being proportional to the movement speed or velocity. Okay? So it could be either this coil moving across the magnet, or we can have the magnet going into the circuit of the electric conductor. Okay, so we have two parts. Hence here they said that if you check here, This happens when a conductor is set in a moving magnetic field when using AC power source, or when a conductor is moving in a stationary magnetic field always. Okay, so you see the two different stages. So this one is where the magnet is moving into an electrical conductor, and when it becomes part of this closed circuit. Or we can have one where the magnet is stationary and these coils or loops are the ones that are moving through this magnet. Okay, so you see the differences now. Okay, I hope that you understand. If you don't, drop me a chat and I will try and explain it again. Okay, so then we can see that the quicker the movement of the magnetic field, the greater the induced electromotive force, or EMF. Okay, EMF is basically a voltage. Okay, electromotive force is a voltage, and here we're specifically talking about the voltage in the coil. Okay, so for Faraday's law to be valid, there must be a relative movement or movement between the coil and the magnetic field, so that the magnetic field, so then the magnetic field, the coil, or both will move. Okay, so one of these things must be moving. It's either you're going to have the coil moving or you're going to have the magnet moving, but one of them or both of them must be moving for EMF to be produced in this case. Okay, so now we go back to the current produced by the magnet. So, okay, before we go far, the galvanometer. The galvanometer is an instrument used for detecting and measuring small currents. So this is the galvanometer here. So this is basically a measuring device. It measures or it detects if there's current, small currents or voltages, then it will start moving up, okay, to show how much of those small currents or voltages you can find there. Okay, so this is what a galvanometer is. A term indeed that you must bear in mind and you must know. Okay, so if more turns were added to the coil, a stronger magnet was used, this would produce more current as well. Okay, so here is our coil. This side is our coil and this side is our magnet. So basically, what they're saying here is that it shows the direction of the current generated by a moving magnet. Okay, that one is a moving magnet and the other one is a moving coil, conducting coil. Okay, so if the magnet is continuously shifted back and forth, the current continues to change direction. Okay, so to put it in another way, alternate AC current is made. So AC current gets to be produced here. Okay, so alternating current is electric current which continues to reverse the direction. Okay, so this is a conducting coil and this one here is a magnet. So how is electromagnetic induction used? How do we use electromagnetic induction? Electromagnetic induction relies on two critical devices, and that is electrical generators and electrical transformers. So both devices, they play a critical role in generating and regulating the electric current on which we rely on our daily lives. So basically, electromagnetic induction is used in the process of generating electricity, which we all need and we can all relate to. So electric generators are using electromagnetic induction to transform kinetic energy into electrical power. They generate electricity in power stations. Okay, so electrical transformers use electric induction to adjust electrical current stress. Some transformers raise voltage and others reduce voltage. So you either have a step up or a step down transformer. So they also use the principle of electromagnetic induction, okay? By increasing the number of turns. Remember, the number of turns is what we see in this coil. So if, for example, in the transformer, they want to increase the electricity, they want to increase the voltage, what will they do? They will add some more turns. Remember, we spoke about that if you add more turns, this can give you more current. So that's what would happen basically. Or if maybe they wanted lesser voltages, they will do what? They will decrease the number of turns. And number of turns is this coil. So this is equals to 1 turn. This is also a turn, and this is also a turn. So if you decrease the number of turns, your current will be so much less. So that's basically the principle that they're talking about in this part of the coils, once they talk about the coils and the number of turns. Okay? So moving on. So basically, the summary that we've learned about the electric field, because I want us quickly to also do there's something that I want us to do in a textbook, an activity that I'd like us to do. So before we do it, I just want to get to the summary of the So electromagnetic induction is a process by which a magnetic field generates electric current. It happens when a magnetic field or an electric conductor passes relative to each other, so that the conductor crosses lines of force in the magnetic field. Okay, so basically it's like cutting the lines of the magnetic field. Okay, so when the magnet or coil moves faster, the coil has more turns, or the magnet is stronger, the current produced by the electromagnetic induction becomes greater. So if the magnet or coil is continuously shifted back and forth, it will produce alternating current. So these are the things that we spoke about. And then, do you see things that affect um, the, the 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 production of electromagnetic induction is if the coil or magnet moves faster. So if the speed of the movement becomes faster, or the coil has more turns, which is what we just spoke about, that if the coil gets to have more turns or lesser turns, it determines how much voltage or current is going to be produced. Or if you have a very strong magnet, because in this for example, now we spoke about generators. It's these huge coils. They're probably as tall as a person is, and those things, you can imagine how much electricity that they produced from those coils. Okay, so the current produced by the electromagnetic induction becomes greater according to these three factors: the movement speed, or the number of turns, or a stronger magnet. Okay, so electrical generators and electrical transformers use electromagnetic induction to generate electricity or to change electrical current voltage. Okay, electrical generators and electrical transformers use electromagnetic induction to generate electricity or to change electrical current voltage. Okay, so now let's go quickly to the book. As I've already told you guys that there's something that I want us to check out. Ooh, I just hope that this is not gonna take long to open up. Okay, it's on Snaplify. Okay. So I don't know why it's giving me a problem with opening up this textbook. But I think I should have tried to put the snapshots. Put the snapshots on. Okay. So if you do possibly have some internet connection, you can check out this lesson on YouTube. Okay. So I'm just trying to find the textbook because there's some stuff that I wanted us to check out. Okay. But it seems that okay. So we are going to have homework that we're going to do, but I just can't seem to find it right now because it's in this textbook and I wanted us to do it here. Okay, so I'm so sorry guys, but this book is not opening up, as you guys can see by yourself. It's a Snaplify reader. It's usually the one that's, got my back, but I don't know what's happening today. It seems that it's not quite doing the magic touch. Okay, so guys, I think that we can still do it by tomorrow. Um, okay, what I'll do is that I will make you make your summary of questions, and I'll also make my summary. But if you do have the Oxford Successful textbook, you guys can just go in there and do those problems. They're not so bad, hey. It's just small little questions, but I'm definitely going to do them tomorrow when before the class starts, before we do whatever we have to do tomorrow. I'll start with those little problems. They're good because they're going to be refreshing your mind with everything that you learned, and it's sort of like a test to check if you are understanding the work that you have been doing. So this book of mine is failing me right now. I can't open it up, but okay. Okay. So I'm sorry about that. Just so for now, just go. You guys can also go and make your own summaries, which will also help you guys to understand electromagnetic induction. But I think um, if you read through the stuff and you are listening to everything, then it shouldn't be so difficult to work towards it. Okay. But nonetheless, guys, I failed to get these questions out of this textbook. Oh, but nonetheless, guys, thank you guys so much for a beautiful class. It's always nice to see people participating and showing interest in physical sciences. Okay, so tomorrow we're going to finish up this part. And from me, Nonkululeko Madondo, I am your physical sciences grade 11 teacher. If you do have queries or there's something that you didn't quite understand from the work that we did, you can get me on T33T ndlovu@gmail.com. It's T33T ndlovu@gmail.com. And you can ask me any question that you'd like to find out with regards to the problems that we did, or some of the questions or some of the definitions that you didn't understand. I'll be gladly there to clarify them for you. So for me, Nonkululeko Madondo, this is the STEM Digital School presented by Africa Teen Geek. My name is Nonkululeko Madondo, and goodbye.